In 2020, Google taught an AI to lay out a chip the way AlphaGo plays Go, treating the placement of circuit blocks as moves on a board. That system became AlphaChip, and AI-drawn layouts have shipped inside every generation of Google's TPU since. This year, the two companies whose software sits behind nearly every chip on Earth, Synopsys and Cadence, both put AI agents to work on real designs. So, can AI actually design a chip? The honest answer today is part of one, and that part is growing fast. This is what the AI can really do, and where it still stops. First, be precise about what designing a chip means. It starts with a specification. What must this chip do? Architects turn the spec into a structure. Engineers write RTL, code that describes the logic, line by line. Verification engineers then try to prove that code correct, and that alone often consumes more than half of the schedule. Physical design turns the logic into billions of transistors and wires on real silicon. And at the end comes sign-off, where a human being takes responsibility that this chip, which will cost millions to manufacture, actually works. Every stage is a search through possibilities, and the search space dwarfs Go by orders of magnitude. Almost all of it runs on software from 3 companies. Synopsys, Cadence, and Siemens hold more than 85% of the market, and at the most advanced nodes, the top 2 are effectively unavoidable. So, can AI design a chip? Is really 3 questions. Which step? How autonomously? And who signs off? AlphaChip went after one step, placement, deciding where the major circuit blocks physically sit on the die. Placement shapes how far every signal travels, so it moves power, performance, and area all at once. DeepMind framed it as a game. The board is the silicon. Each move places a block. You win by producing a layout that scores better than the human one. Trained with reinforcement learning, the system delivers layouts in hours, comparable or better than experts who need weeks or months by Google's own account, and it's shipped. 3 straight generations of TPU, V5e, V5p, and Trillium carry AlphaChip layouts, handling more of the floor plan each generation, and so do Google's Axion server processors. Then there is the fight. Veteran EDA researcher Igor Markov cataloged 16 methodological doubts in communications of the ACM. A university team led from UC San Diego reported it could not reproduce the published results. Its paper is titled "The False Dawn." DeepMind answered with a rebuttal titled "That Chip Has Sailed," and the original journal reviewed the work and let it stand with an addendum. There is still no consensus. So hold both facts. The production adoption is real, and so is the dispute. Now the vendors. This February, Cadence launched ChipStack, calling it the world's first agentic workflow for chip design and verification. A so-called super agent takes a specification, breaks it into tasks, writes the test benches, orchestrates regressions, debugs failures, and fixes them, with a headline claim of up to 10 times productivity on those jobs. It stands on AI Cadence has shipped for years. Optimization engines used in more than 1,000 tapeouts. Early customers put out their own numbers. Altera reported verification effort down roughly 10 times in some areas. Tenstorrent measured up to 4 times faster verification across a 3-month evaluation. NVIDIA and Qualcomm are in the program too. 1 month later, Synopsys answered at its Converge conference with Agent Engineer and borrowed the language of self-driving cars. Level 1 is a co-pilot answering questions. Level 5 is full autonomy. Most of what ships today sits at the co-pilot and task agent levels, but on stage Synopsys demonstrated what it calls the industry's first Level 4 workflow. From natural language spec to RTL, lint checks, test bench, and iterative verification. Compressing work, it says, normally takes 4 to 6 months. Customers report doubled productivity, up to 5 times in select cases. Notice what every number here shares. It is vendor or customer self-reporting. Discount the decimals. The direction, though, is loud. The chipmakers are not waiting for their vendors. NVIDIA built ChipNeMo, a language model trained on its own design documents, code bases, and bug archives, data no public model has ever seen. The payoff of that specialization, a 13 billion parameter model that matched or beat 70 billion parameter general models on chip design tasks. Inside NVIDIA, it plays the patient senior engineer, answering junior designers' questions, summarizing bugs and routing them to the right team, writing scripts for the design tools. Bill Daly, NVIDIA's chief scientist, describes where this goes. A master agent directing specialist sub-agents that meet and negotiate the way a human design team does. Google, meanwhile, keeps AlphaChip in production, generation after generation. And here is the tell. NVIDIA, with one of the deepest AI benches on the planet, still signed on as an early customer for Cadence's agents, and this April, the two companies announced a broader AI partnership on top. When the company that builds its own chip design AI also buys its EDA vendors, that is not marketing enthusiasm. That is a team short of engineering hours, taking help from every direction it can get it. Investors have noticed. Chip agents raised $50 million this year, $74 million in total, and says its design and verification agents are deployed at 80 semiconductor companies. CogniChip raised $60 million to build a foundation model for chip design itself, trained for silicon from the ground up, rather than a general chatbot wrapped in a new interface. Normal Computing raised $50 million in a round led by Samsung's venture arm, betting that welding language models to formal logic can make AI-written hardware provably correct. All of them are selling the same hope, that AI-native tools can crack open a market two giants have owned for decades, but everyone in this race hits the same wall. In software, a hallucinated line is a bug report. In silicon, if it slips past verification, it is a respin, months of delay and millions of dollars etched into a mask set. Sign-off is a question of accountability, and you cannot hold an agent accountable. Training data is scarce because real chip designs are trade secrets that never leave the building, and the veterans on the conference floor remain openly skeptical. Nobody, not Google, not the duopoly, not the startups, has yet taken a chip from specification to tape-out with AI in charge. So, can AI actually design a chip? Hold both halves of the answer. Yes, AI already designs parts of real chips in production today. Placement layouts inside Google's TPUs, verification workloads cut several-fold in the words of early customers, an autonomy ladder that climbed from co-pilots to a demonstrated level 4 faster than most skeptics expected. And no, nobody hands AI the whole chip. The AlphaChip dispute is a standing warning label on every impressive claim, and each multiplier you heard today came from a vendor or its customers. What changes first is the shape of the job, engineers moving up from writing every line to directing agents, reviewing their output, and owning the signature at the bottom of the page. And notice who collects either way. The companies selling the agents. Whichever AI wins the design floor, design teams pay the duopoly for it. It is the same pattern this channel keeps finding across the supply chain. The tools above the fight get paid no matter who wins it. If you want the origin story, we have already covered how just two companies came to control the software every chip needs, and whether AI can replace a verification engineer, the job this wave touches first. Both are linked below. Subscribe for the actual semiconductor industry view. Grounded, even-handed, no hype. Thanks for watching.